Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have already understood what is a transition diagram and what is a transition table of a DFA. And now in this lecture, that is problems on DFA set 1, we are going to understand few interesting problems on DFA. So in this lecture, we will understand total 4 problems on deterministic finite automata. So let's get started with our very first problem. Let's read this problem together. Design a transition diagram of a DFA that accepts all strings beginning with 0 over the alphabet 0, 1, which means we are required to design a transition diagram of a deterministic finite automata which will accept every possible string of 0 and 1 that is beginning with the symbol 0. That means our DFA should accept all the strings beginning with 0 and should also reject all the strings beginning with 1. That means our DFA should be able to handle both the scenarios, accepting the strings starting with 0 and rejecting the strings starting with 1. So now let's start our solution. First of all, this is the language of our DFA. The language set L contains all the strings that are valid according to the problem statement. Here you can see all the strings are starting from the symbol 0. That means these all strings are valid strings. And our DFA should be able to accept all these valid strings and should be able to reject all the invalid strings. Now, before designing the DFA, let me tell you 3 important steps that we will follow during the designing of our DFA. Step number 1 is you will need to select the simplest possible string from this language. And here you can see the simplest possible string out of these string is 0. In the step number 2, you are required to draw the transition diagram to accept the simplest possible string. And the last step is you need to complete all the transitions for all the states in the DFA. So while constructing the transition diagram to accept the simplest possible string, there may be many missing transitions. So in step number 3, we will complete those missing transitions. So now let's start designing our deterministic finite automata, which will accept all the strings beginning with 0. So the step number 1 is select the simplest possible string. And we already know 0 is the simplest possible string here. Why? Because 0 is of length 1 and the string 0 is also beginning with the symbol 0. Now in the second step, we will draw the transition diagram to accept this simplest possible string. So first of all, we will have our initial state, that is Q0, and on getting the input symbol 0, it will reach the final state or the accepting state. Let's say Q1, because 0 is a valid string, that is why it will be accepted. So we have completed our step number 2, in which we have drawn the transition diagram to accept the simplest possible string. Now in the step number 3, we will try to complete all the missing transitions of this diagram. You can see that the state Q0 has the transition for input symbol 0, but there is no transition for input symbol 1. Similarly, for the state Q1, the transitions for both input symbols 0 and 1 are missing. So let's try to complete all the transition. Let's start with state number Q1. At Q1, you can see 0 is already processed. That means we have got our first symbol as 0. And according to the question, if the first symbol is 0, DFA will accept that string. So it doesn't matter what comes after that 0. So any combination of 0 and 1 will be accepted that will come after 0. So we will simply create a self loop for the symbol 0 and 1 over the state Q1. And in this way, we have completed both the transitions for the state Q1. And now we will try to complete the transition for state Q0. Here you can see Q0 already has a transition for 0 but doesn't have a transition for 1. Now, if we get the first symbol as 0, the string is getting accepted. But if the first symbol is 1, then the string will get rejected. And to reject the string, we will reach a state which is called as dead state. And from dead state, you can never go to the accepting state again. Because once the string starts with 1, it can never start from 0. So I hope this diagram is now clear to you. Now I think we have completed all the 3 steps of designing a DFA. So do you think this is a valid DFA? No, it is still not a valid DFA. Though we have completed the transitions for the state Q0 and Q1, but we also have the state Q2, and we have still not completed the transitions for the state Q2. Now, if the first symbol is 1, it doesn't matter what comes after that, because once the string is started from 1, it will be rejected. So after that, if we get any other symbol, we will still remain at the dead state. And for this reason, we will simply create a self loop for both the input symbols 0 and 1 over the state Q2. Now we can say that this is a valid DFA. So after designing the DFA, I will write the 5-tuple representation of the DFA. Here we have the 5-tuple representation of DFA. Our DFA M is the collection of 5 elements: Q, sigma, delta, Q0, and F. These 5 elements are used to entirely represent a deterministic finite automata. Every part of this DFA can be represented using these 5 elements. Now let's see the values of these 5 elements. Q, which we already know, is the set of states. And in this DFA, we have total of 3 states: Q0, Q1, and Q2. So the set Q will have 3 elements: Q0, Q1, and Q2. Sigma is the set of symbols, and we have only 2 symbols, 0 and 1. So it has 2 elements, 0 and 1. Now delta is the transition function, which is the collection of transition rules. In this DFA, we have 3 states and 2 input symbols. That is why we will have total of 6 transitions. So Q0, on getting input symbol 0, the next state is Q1. Similarly, Q0, on getting input symbol 1, the next state will be Q2. Q1, on getting input symbol 0, the next state is Q1 itself. So in this way, I have written only 3 transitions, and I want you all to write the remaining 3 transitions in the comment section. Now, the next element is Q0, which is the initial state of the DFA. And in this DFA, Q0 is the initial state. So the value of Q0 is Q0. F is the set of final states, and in this diagram, Q1 is the only final state. So this set will contain only one element, which is Q1. So by this, we have completed with the 5-tuple representation of this DFA. Now we will quickly understand the construction of transition table for this DFA. Here is the transition table of this DFA. In the first column, I have written the states that are Q0, Q1, and Q2. In the first row, I have written the input symbols that are 0 and 1. And in the remaining cells, I have written the next states. So Q0, on getting the input symbol 0, will reach the state Q1. You can check. Q0, on getting the input symbol 0, will reach the state Q1. Similarly, Q0, on getting input symbol 1, will reach the next state, which is Q2. Now Q1, on getting both the input symbols 0 and 1, will remain at the same state Q1, and similarly Q2 will also remain at the same state Q2 on getting input symbols 0 and 1. So in this way, we have solved our problem number 1, in which we have written the language, drawn the transition diagram, then we have seen the 5-tuple representation of the DFA, and after that we have constructed the transition table. So keep this thing in mind. Whenever you will encounter any question on DFA construction, first of all, you have to write the language, then you have to draw the transition diagram, Then you have to write the 5-tuple representation of DFA, and at last, you need to construct the transition table for the DFA. So now let's proceed to our second problem, which is design a transition diagram of a DFA that accepts all the strings ending with 10 over the alphabet 0, 1. That means in this problem, we are required to design the transition diagram of a DFA that will accept all the strings ending with 10. So our DFA should accept all the strings ending with 10 and should be able to reject the strings not ending with 10. So let's see the language for this problem. In this language, you can see all the strings are ending with 10. So these strings are valid strings, and our DFA should accept these valid strings and should also reject the invalid strings. Now, for designing the transition diagram of the DFA, we will follow the same steps that we have followed in the previous question. Step number 1, select the simplest possible string. In these strings, the string 10 is the simplest possible string because it is the smallest, and 10 is beginning with 10 as well as ending with 10. So this is going to be our simplest possible string. Now in step number 2, we will draw a transition diagram to accept this string 10. So first of all, we will have our initial state, that is Q0. On getting the input symbol 1, we will reach an intermediate state, let's say Q1. And after reading the last symbol, which is 0, our whole string is processed now, that is 10. So we will reach the accepting state, that is Q2. In this way, we have completed our step number 2, and we have drawn a transition diagram to accept the simplest string, that is 10. Now in the step number 3, we have to complete all the missing transitions of all the states. Q0 has a transition for symbol 1 but doesn't have a transition for 0. Q1 has a transition for 0 but doesn't have a transition for 1. And Q2 doesn't have a transition for 0 as well as 1. So let's start with Q0. In the question, we can see that our DFA should accept all the strings ending with 10. So if the string is ending with 10, we can have any number of zeros before that. It doesn't matter what comes before 10 if the string is ending with 10. So I will simply create a self loop of the symbol 0 over the state Q0. In this way, we have completed both the transitions for the state Q0. Now let's talk about the state Q1. Now Q1 has a transition for input symbol 0, but it doesn't have a transition for 1. So if I get input symbol 1 at Q1, I need to remain at the same state so that my string ends with 10. And for the state Q2, I don't have any transition for 0 or 1. And you can already see that 10 is already processed. So if I get another 0 after 10, it will destroy the whole pattern. And I need to go back to the state Q0 so that my string ends with 10. And if I get the input symbol 1, then I will go back to the state Q1 so that my string ends with 10. So this was the transition diagram for the problem number 2. And now I'm not going to write the 5 elements of this DFA. But in examinations, you are required to write the 5-tuple representation of the DFA after drawing the transition diagram. And here is the transition table for this DFA, and you can simply check the next states. So we have solved the problem number 2, and now we will proceed to problem number 3. Design a transition diagram of a DFA that accepts all strings having substring BAB over the alphabet A, B. That means our DFA should accept all the strings having BAB and should reject the strings which do not have BAB. So that means what comes before BAB and what comes after BAB doesn't matter. Your string should contain BAB. If we see the language, you can see all the strings are the valid strings because in this string we have BAB, in this string we also have BAB, here you can also see BAB, and in this string also you can see BAB. In this string, we have just BAB. Here, BAB is at ending. Here, BAB is at starting. And in this string, we have BAB in somewhere middle of the string. That means the position of BAB doesn't matter. What comes before BAB and after BAB doesn't matter. It should just contain BAB. So now let's draw the transition diagram for this problem. So we'll select the simplest possible string, which is BAB, and we'll have our initial state, that is Q0. On reading the input symbol B, we'll reach an intermediate state, that is Q1. On reading the input symbol A, we'll reach again an intermediate state, that is Q2. And after reading the last symbol, which is B, our entire string is processed now, that is BAB. So we'll finally reach the accepting state, let's say Q3. Now, I will complete the transition for all these states. Q0 has a transition for B, but it doesn't have a transition for A. And as per the question, our string should contain BAB. And if the string is already containing BAB, it doesn't matter what comes before BAB. So we can have any number of A. So for this reason, I will simply create a self loop of A over the state Q0. Now, for the state Q1, I have a transition for A, but I don't have a transition for B. So if I get input symbol B at Q1, I will remain at the same state so that my string contains BAB. For the state Q2, I have transition for B, but I don't have any transition for A. And you can see the string BA is already processed. So if I get the input symbol A, the string will be like BAA, which will destroy the whole pattern. So I again need to go back to the state Q0 so that my string contains BAB. Now, for our accepting state Q3, we can see that the string BAB is already processed, which means our string contains BAB. So what comes after BAB, it doesn't matter. So we can have any combination of A and B for the state Q3, and for this reason, we'll simply create the self loop for the symbols A and B over the state Q3. So this was the transition diagram for our problem number 3. Now let's proceed to our problem number 4. Design a transition diagram of a DFA that accepts all strings having length 3 over the alphabet A, B, which means we are required to draw a transition diagram of DFA that accepts all the strings having length equal to 3. Now, length of a string I have already told you. Length of a string is defined as the number of symbols in that string. That means this DFA should only accept the strings which have number of symbols equal to 3, and it should reject the strings having number of symbols less than 3 or greater than 3. So let's see the language. In this language, you can see all the strings are having length equal to 3. And this is an example of a finite language. In the last 3 questions, we were having the infinite language. But here you can see that there are only 8 strings having length 3, and that is why this is a finite language. Now, we will start constructing our deterministic finite automata for this language. Here you can see that there is no particular simplest possible string because all the strings have the same length. So we will consider all the strings while designing our DFA. First of all, we'll have our initial state, which is Q0, and now we will read the first symbol. In these strings, you can see the first symbol can be either A or B. So we can have the first symbol as either A or B, and we will reach our state Q1. Again, we will process the second symbol, and the second symbol can also be either A or B. So we will read the second symbol, which is A or B, and we will reach the state Q2. 2 symbols are already processed, and now we are going to read the third symbol. In these strings, the third symbol can also be either A or B. So we will read the third symbol, which can be either A or B, and finally we will reach our accepting state, that is Q3. So these 3 states will reject the strings having length less than 3, and this state will accept the strings having length equal to 3. But what about the strings having length greater than 3? So if I read one more symbol from A and B, I will reach that state because now the length of the string is greater than 3. And at dead state, if I get any other symbol, the length of the string will still be more than 3. So I will remain at the same state, which is the dead state. So this was our transition diagram. Now tell me, is this a complete DFA? Yes, this diagram is a complete DFA because for every state we are getting the transitions for both the input symbols. For example, for state Q0, we are getting the transition for input symbol A as well as for input symbol B. And similarly for all the states, we have both the transitions. So this is a complete and a valid DFA. And I hope you can simply construct the transition table for this DFA. In this way, we are done with the problems on deterministic finite automata. And in the next lecture, we will solve few more varieties of problems on DFA. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.